Welcome, dear learners. We are continuing Unit 1, Chemistry as a Science Discipline and Scientific Analysis. The present module is entitled Chemistry in Daily Life. The contents of this module are impact of chemistry in human life, food chemistry, the food additives, medicines, cleansing agents, discussion on soaps and detergents, chemistry in industry. First of all, impact of chemistry in human life. It should be noted that chemistry is there in everyday life. That is, every aspect of everyday life is related to chemistry. The food we eat, the medicines we take, the soap, the toothpaste, etc. we are using, all are different kind of chemical compounds, or all of them contain various kind of chemical species. Thus, chemistry has a very strong impact in human life. Let us move on to some details of the impact of chemistry in human life. Chemistry profoundly impacts nearly every aspect of human life, often in ways we could not immediately recognize. Medicines and health care. Chemistry is highly important in drug development, in the development of diagnostic tools, in the preparation of vaccine. In all this area, the interface of chemistry is very remarkable. Food and nutrition is another area where chemistry has most significant contribution. Food preservation, that is the development of various kind of food preservatives, chemistry has a pivotal role. Nutritional enhancements, food flavoring agents and food additives are all different kind of chemical compounds. So, chemistry has remarkable contribution in food and nutrition. Now, environment and sustainability. For sustainable development and environmental protection, the role of chemistry is highly remarkable. Chemistry is significant in pollution control. Even though several chemical compounds causes pollution problems, we can avoid, we can prevent, we can control pollution with the help of the concepts of chemistry. Renewable energy and energy production, energy harvesting, development of solar cells, etc. are major impact of chemistry in our daily life. Green chemistry is a branch of science which deals with eco-friendly chemical species, their usage, their promotion, etc. So, environment and sustainability is a major area where chemistry has strong impact. Now, daily life applications. The application of chemistry in day-to-day life is highly remarkable. The cleansing products like soap, detergents, hand wash, etc. we use are different kind of chemicals. The clothing we are using is mainly made up of some artificial and synthetic natural fibers, etc. All these fibers contain some polymeric materials, some natural polymers, etc. Some processed polymers, some semi-synthetic polymers, etc. are highly useful in the preparation of clothings. Cosmetics and personal care is also a very important contribution from chemistry. Now, industry and technology is also supported by chemistry. That is, chemistry has its remarkable contribution in the development of various kind of industries, several technologies, and it supports economic growth of the country also. Material science, in which we are developing various kind of nanomaterials with the high performance, enable the industrial development. Nanoelectronics and recent materials for the development of electronic components is also a major contribution from chemistry. Energy production, energy usage, energy harvesting, etc. will also support industry as well as technology. All this has a significant contribution from the branch chemistry. Now we are discussing food chemistry. Food chemistry is the study of the chemical composition, processes and interactions of all biological and non-biological components of food. That is, food chemistry is nothing but chemistry of food. The food chemistry bridges chemistry, biology and nutrition science to understand how food's molecular structure affects its taste, texture and nutritional value as well as safety. So, the structure of food molecules, the taste of food molecule, texture, the nutritional value of the food, etc. has strongly governed by the branch chemistry. Now we are discussing another important part of food chemistry, that is nothing but food additives. You heard about several kind of food additives like antioxidants, food preservatives, flavoring agents, artificial sweeteners, etc. All these kind of compounds come under the category of food additives. So, the food additives are edible chemicals. They should create minimum toxic effect in the organism. We are now discussing various type of food additives with relevant examples. First of all, the definition of a food additive. What are food additives? Food additives are chemical substances which are added to food to improve flavor, texture, color and appearance and consistency, or the compounds are added as preservatives during their processing. So, we are generally use food additives to improve the flavor, taste, color, appearance as well as consistency. Now, main categories of food additives are discussing here. The first category is food color. Color is very important as far as the appearance of a food item is concerned. A food item with a beautiful color will immediately catch our attention. There are so many kind of food colors. The food colors may be natural food color or synthetic food color. Natural food colors are isolated from several natural sources. Synthetic food colors are those coloring agents which are chemicals that is prepared in chemical laboratory. Synthetic coloring agents have several side effects even though they are still used for coloring different kind of food items. So, food colors are a major category of food additive. Next food additive is flavors and sweeteners. Flavors are materials used to give tastiness to the food item, and sweeteners are used to impart high sweet taste to the food item. Another category is fat emulsifiers and stabilizing agents. These materials are also added to food item for better stability of the food item. Next category of food additive is floor treatment agents. Another category is antioxidants. Antioxidants, as the name indicate, they are a category of compound which are used to prevent oxidation reaction. Unnecessary oxidation reaction that occur in animal body can be prevented with the aid of antioxidants. There are so many antioxidants. We can enter into details of the antioxidants in coming slides. Another category of food additive is food preservative. Food preservatives are materials which are used to preserve the food item, to preserve the food from degradation, etc. Another category is nutritional supplements. These are materials which are added to the food item to increase its nutritional value. Thus, we have discussed several kind of food additives. Now we are focusing on some special categories of food additives in detail. First of all, flavors and sweetness. Flavors or flavor enhancers are used to improve the flavor and aroma of a food. Aroma means a smell. Smell of a food can be improved with the help of flavor enhancers. Most common example for flavor enhancer or flavoring agent is monosodium glutamate or MSG. Another one is calcium glutamate. Ethyl maltol is another example. You are familiar with the MSG. MSG is monosodium glutamate. Monosodium glutamate is the sodium salt of naturally occurring amino acid, that is glutamic acid. You are familiar with the amino acid molecules. What are amino acids? Amino acids are the molecules, organic molecules, which contain amino group, that is NH2 group, and COH group in a single molecule. Simplest amino acid is glycine. This amino acid, the glutamic acid, is an acidic amino acid. It contains more than one COOH group, and its monosodium salt is abbreviated as MSG. MSG is known by you under the name Ajinomoto because Ajinomoto is the trade name of MSG. However, even though it is enhancing the savory taste of a food item, the prolonged use of this MSG causes a disorder or a syndrome known as Chinese restaurant syndrome. Now, sweetness. You are all familiar with the sweetness also. As the name indicates, sweeteners are materials which provide sweet taste for fewer kilojoules and calories than sugar. The advantage of sweeteners, artificial sweeteners, is that they have comparatively less calorie in energy compared to sugar, but their sweetness, they provide high sweetness compared to sugar. So, provide low energy and high sweetness compared to sugar. Some typical examples for artificial sweetness are here. First one, aspartame. This is the chemical structure of the molecule aspartame. You can see the presence of an aromatic ring here. So, this aspartame as a sweetener, it has 100 times more sweetness than sugar, or aspartame can offer 100 times sweetness than sugar. Another artificial sweetener which is commonly used in food preparation is saccharin. This is the chemical structure of saccharin. The saccharin molecule can offer 550 times more sweetness than sugar. So, sweeteners are chemical species which can provide sweet taste but with lower calorie compared with the sugar. Antioxidants. I already mentioned about the compound antioxidant. Antioxidant is a molecule that inhibits unnecessary oxidation that may occur in the biological system, in the organism. Or antioxidant prevents the oxidation of other molecules present in the body. As a food additive, this antioxidant retard or prevent oxidative deterioration of food. Many of the food items will get degraded due to unwanted oxidation. If antioxidants are present, they can prevent to a better extent unwanted oxidation can be prevented. And such agents are termed as antioxidants. Some common examples of antioxidants are here. They are nothing but BHA or butylated hydroxyanisole, BHT, that is butylated hydroxytoluene. Moving on to another category, that is nothing but preservatives. Preservatives protect against deterioration caused by microorganisms. The preservatives used in food can be broadly divided into two categories. The first category is class 1 preservative. They are natural preservatives like sodium chloride, vinegar, etc. But the second category, class 2 preservative, consists of chemical compounds which are synthesized in the laboratory, and a typical example for a class 2 preservative is sodium benzoate. So we are using preservatives to protect the food item against deterioration caused by microorganisms. Now we are discussing another important contribution from chemistry towards daily life, towards human, towards animals, that is nothing but medicines. We are now focusing on the medicines. Medicines all are chemical compounds. We are now discussing medicines, medicinal chemistry and various kind of compounds which are used as different kind of medicines. First of all, chemistry in medicine. As we know, one of the most remarkable applications of chemistry in the field of medicine is in the field of medicine and health care. Chemistry has a strong impact, strong contribution towards medicine as well as health care. Drugs are chemicals which are able to produce a biological response. When a biological response is therapeutic and useful, the drugs are called medicines. These two statements give you clear idea to differentiate drugs from medicines. You should keep the fact that all drugs are not medicines, but all medicines are drugs. Drugs are chemicals which can provide a biological response. If that biological response has some therapeutic application, only that drugs are termed as medicines. So, all medicines are drugs, but all drugs are not medicines. Where do drugs come from? This is a simple question to you. All drugs contain chemicals. They may be from natural source like plants, animals, fungus, etc. Or they may be created in laboratory. So, drugs, all drugs are different kind of chemical compounds which may be of natural origin or artificial origin. Have you noticed the notation RX in prescription sheets? You may be noted that the term RX is used as an abbreviation of the word prescription. It is actually a contraction of the Latin word recipere, which means take. So, whenever you look on the prescription sheet written by a doctor, it is beginning from the term RX. It means prescription. Now, category of drugs. In the coming few slides, we are discussing different category of drugs which are highly useful as far as medicinal chemistry is concerned. Let us have a glimpse on therapeutic effect of some important category of drugs. Do you know this compound? This compound is a phenol. Its para position consists of NHCOCH3. This compound is highly familiar to you, and this is paracetamol. Paracetamol is acetaminophen. What is the purpose of using paracetamol? It is a very popular compound. It is a pain reliever as well as a fever reducer. Pain reliever means analgesic. Fever reducer means antipyretic. So this paracetamol is antipyretic as well as analgesic. Now, what are antipyretics? As I just mentioned, antipyretics are used to reduce the body temperature. There are several examples. Aspirin or acetyl salicylic acid, even though it is widely used to relieve the body pain, it can have the capability to reduce the body temperature also. So, aspirin is a good example for antipyretic. Next one, paracetamol, phenacetin or 4-ethoxyacetanilide. All these compounds are very remarkable antipyretics. Another category of drug is nothing but antacid. You know about acidity problem that may occur in your stomach. What is the reason for that acidity problem? Overproduction of acid in the stomach causes irritation and pain. Antacids remove excess of acid present in your stomach and raises the pH. So many examples are there. Magnesium hydroxide, magnesium carbonate, gelatinous aluminum hydroxide, sodium bicarbonate, omeprazole, etc. are good antacids. The picture represents the chemical structure of the last compound, last antacid, that is omeprazole. Another category of compound or drug is antihistamines. Antihistamines are otherwise called anti-allergic drugs. That is, antihistamines are the chemical species or drugs used to treat allergy. Several examples are there. Cetirizine is a very popular anti-allergic compound. Diphenylhydramine and chlorpheniramine are other examples for anti-allergic drugs or antihistamines. Another category of drug is analgesics. Analgesics, also called painkillers, are chemical species that relieve different type of pain, from headache to injuries to arthritis. Different kind of pains that may occur in your body can be treated, or pain can be relieved, or pain can be reduced with the help of this category of drugs, that is nothing but analgesics. Now let us have some examples on analgesics. The analgesics are broadly classified into two different categories. The first category is narcotic analgesics. They contain compounds like morphine, derivatives of morphine like codeine, heroin, etc. Usage of this narcotic drug must be under strict control and strict follow-up of the rules and regulations. Now, non-narcotics. Non-narcotic analgesics include chemical compounds such as aspirin, Novalgin, ibuprofen or simply brufen, naproxen, diclofenac sodium, and even paracetamol. So, analgesics are medicines used to reduce the body pain. Another category of drug is antiseptic. What are antiseptics? Antiseptics are used to kill or prevent the growth of microorganisms. They are not harmful to living tissues. Examples include Dettol. Dettol is a chemical compound, alpha terpineol and chloroxylenol. Its mixture is known as Dettol. Tincture of iodine is another example of antiseptic. Iodoform, Salol or phenyl salicylate are very good examples for antiseptics. Now, whenever we are dealing with antiseptics, we have to consider this term also. Disinfectants. What are disinfectants? How they differ from antiseptics? This is an important question. Disinfectants are used to kill microorganisms, but these are harmful to living tissues. Remember the fact that antiseptics are not harmful to living tissues. 1% phenol and sulfur dioxide are good examples for disinfectants. Lysol is a disinfectant, but remember, Dettol is an antiseptic. So, antiseptic will not affect the host cells or living tissues. However, disinfectant can kill microorganisms as well as they are harmful to the living tissues or the host cells. Another category of drug we are discussing here is antibiotics. Antibiotics are produced by microorganisms like bacteria, fungus, different kind of molds, etc., which can prevent the growth of microorganisms. It is quite interesting. The antibiotics are produced by microorganisms, and these microorganisms produce antibiotics. That antibiotics can kill other kind of microorganisms. So, they are produced by microorganisms itself, which can be used to kill or prevent the growth of other microorganisms. Alexander Fleming was the discoverer of the first antibiotic, that is nothing but penicillin. He isolated penicillin from the fungus Penicillium notatum. There are several other examples also. Other kind of antibiotics include tetracycline, ofloxacin, chloramphenicol, etc. Antibiotics can be classified into broad spectrum and narrow spectrum antibiotics. That is far beyond the scope of this discussion. Broad spectrum antibiotics can kill a wide range of microorganisms, whereas narrow spectrum antibiotic can kill only a short range of microorganisms. Now it should be noted that antibiotics do not work against viruses. You are familiar with the disease situation like a cold, flu, etc. But the disorder, cold, flu, etc. cannot be prevented with the usage of antibiotics because they all caused by viruses. That's why we have to say antibiotics do not work against viruses. Now we have to develop medicines against viruses. Such category of drugs are called antiviral drugs. These are some examples of antivirus drugs which kill different kind of viruses. Both are shown in the tabular form here. Acyclovir prevent herpes virus. Oseltamivir is used to prevent or cure influenza. Tenofovir is for hepatitis C. Combivir for HIV. And the last one, remdesivir, is a highly useful medicine that we have used during the time of the COVID pandemic, which is used to treat COVID-19 virus. Remdesivir, during COVID-19 pandemic, remdesivir was approved or authorized drug for emergency use. The chemical structure of remdesivir, which is a very popular medicine against COVID-19, is shown here. This is a popular antiviral drug. Now, tranquilizers. These are other category of drugs. What is the purpose of using tranquilizer? This is used to prevent, this is used to treat people suffering from mental agitation. Or tranquilizers are used for the treatment of stress, mild and severe mental diseases. They can relieve stress and fatigue. So many examples for tranquilizers are there. Some examples are shown here also. Derivatives of barbituric acid, collectively called barbiturates, are good tranquilizers. Veronal, luminal, seconal, etc. are nice examples for tranquilizers which are used to treat mental illness. Cleansing agent is another area where we are using chemistry or chemical compounds for cleaning purposes. Cleansing agents are substances used to remove dirt, grease, even microorganisms and impurities from the surface, including skin, fabrics, different kind of utensils or vessels and other kind of materials. Type of cleansing agents: soaps, detergents, shampoos and body washes, surface cleansers, enzymatic cleansers, disinfecting cleansers, etc. are different kind of cleansing agents. We are giving emphasis to soaps and detergents in this presentation. We are taking soaps now. You all familiar with the compound soap. What are soaps? Soaps are sodium or potassium salt of higher fatty acids. The higher fatty acid contain more than 15 carbon atoms. They may be palmitic acid, stearic acid, oleic acid, linoleic acid, etc. The molecular formula of palmitic acid is C15H31COH. It contains a total of 16 carbon atoms. And the next one is other higher fatty acid, that is stearic acid. It contains a total of 18 carbon atoms and the molecular formula is C17H35COOH. If we are taking sodium or potassium salt of these kind of higher fatty acid, we will get their sodium or potassium salt, and that is nothing but soap. Now, based on the alkali used for the production of the soap, there are two kinds of soaps. They are nothing but the hard soap and the soft soap. What is the peculiarity with the hard soap? For the hard soap, the alkali used in the preparation is sodium hydroxide. That's you can call hard soap a sodium salt of higher fatty acid. However, if you are using potassium hydroxide, you will get a potassium salt of higher fatty acid. The potassium salt of higher fatty acid are known as soft soap. The first category is used for washing purpose and the second category is generally used for bathing purpose. Moving on to other category of cleansing agent, that is nothing but detergents. Detergents are non-soap cleansers. They are compounds other than soaps that exert its effect by lowering the surface tension of an aqueous cleansing mixture. Detergents can be used both in soft as well as hard water. That is the most important advantage of detergent over soap. You know the fact that the soap will form a precipitate with the hard water. So you cannot use soap in hard water for washing or bathing purpose. But detergents can be used even in hard water also. There are several kinds of detergents. Detergents may be anionic, cationic, non-ionic. Different categories of detergents are there. Some typical examples are shown here. Sodium alkyl sulfate, alkyl benzene sulfonate, cetyl trimethyl ammonium bromide, etc. are good examples for detergents. Now, chemistry in industry. You know about the contribution of chemistry towards industry. Several industrial processes for the preparation of compounds are chemical reactions. Thus, we can say chemistry plays a pivotal role in industries worldwide by driving innovation, manufacturing process and product development. Industrial chemistry is the branch of chemistry which focuses on transforming raw materials into useful products through reactions and processes. For example, contact process is a manufacturing process of sulfuric acid. Sulfuric acid can be manufactured by contact process. Haber-Bosch process is used for the manufacture of ammonia. Manufacture means large scale production. In industry, we are looking on large scale production. So for that purpose, we are using some industrially useful chemical reactions. Important areas of industrial chemistry are described here. Petrochemical industry, where we are dealing with the various kind of petrochemicals. The chemicals isolated from petroleum are collectively termed as petrochemicals, and the petrochemical industry is a very important branch of industrial chemistry. Other area of industrial chemistry is intended to prepare various kind of drugs and medicines. They are collectively called the pharmaceutical industry. Food industry is also there. Textile industry is the industrial processes used to prepare various kind of textile items. Polymer and plastic industry is also there. And last but not the least, industrial chemistry has one prominent branch, that is fertilizer and agrochemical industry. That all about the present module. Have a very nice learning experience. Thank you.